What's going on, everyone? This is Alex, USA Days. So today we're continuing with Learn Quality Assurance from scratch, and we're getting into SQL introduction. So this topic is a little bit more complex, so I'm gonna break this video in parts, in shorter parts. But the plan is we're gonna learn about SQL in general, what it is, and we're gonna practice. So this is gonna be hands-on during the video. Just follow the links that I have provided in the description. Pause the video, type out the commands yourself so you can actually practice and learn SQL this way, because really the only way you can learn this stuff is by doing. All right, so we are pretty much at section 8 right now, so it's been a journey, quite a journey. So we covered a lot of topics already. We introduced the basics. We went into some commands that you have to know through Git, console commands, how to do documents, how to file bugs, different types of testing, all of that. So right now we're in SQL introduction. This is a basic SQL. This is not advanced SQL, but this is going to be enough to get you going with your testing. You will be able to retrieve data from database using SQL commands, analyze this data, test this data, and maybe even update some values in the database if needed. After that, we're going to proceed. Next section will be into the API testing. All right, so let's get into the SQL. So what is SQL, right? What it is, right? Pretty much it's a programming language that works with a specific SQL-based databases, right? And what is database? Well, anytime you're on a web page and you reach for some information, let's say you're in Instagram and you're opening your friend's profile page and your friend uploaded some new photos. So those photos, your phone, your app reaches the server, server talks to the database, database sends those files to the server, and then server transfers them to your phone. So basically the data that is stored in different databases, right? Databases are organized collections of data that can be stored, managed, and retrieved in various ways. There are several types of databases, each designed to serve specific purposes and cater to different data management needs. You will mostly find SQL and NoSQL databases. So SQL databases are the databases that use SQL language that we're going to learn today, practice today. NoSQL databases are databases that don't use SQL language. SQL stands for Structured Query Language, and SQL databases are relational databases that are structured using tables with rows and columns. They use an SQL language to manage and query data. Examples of databases that use SQL, and you might have heard some of them: MySQL, PostgreSQL, Oracle Database, Microsoft SQL Server. Now, if you think about SQL database and you think, okay, what can I imagine in my head? Like, okay, how does it look like? What is it, right? Where's the information? How is it stored? You can think about a spreadsheet or a payroll or like a schedule, right? Where you have columns that define what sort of data is stored with within those columns, and rows of data for each record, pretty much like a spreadsheet. Uh, just that spreadsheet has multiple tables, not just one table, multiple tables that store different data. Then there are NoSQL databases. So databases that do not use SQL, and they are designed to handle large volumes of unstructured or semi-structured data and provide greater flexibility and scalability than traditional relational database. For example, Amazon DynamoDB, MongoDB, Cassandra, and many, many more. You can think about NoSQL databases in terms of like Word documents. So SQL database is like a spreadsheet, Excel spreadsheet. NoSQL database is more like a Word document, right? SQL database is structured. It is relational. NoSQL database, more again like a storage where there's not a lot of relational, less relation. There are advantages of disadvantages using one versus the other. SQL is still very popular, so and often companies might have different projects that might need different databases depending on the project. But SQL is still a preferred choice, like for startups, small projects, project that needs an organized, manageable database. So we're going to go with SQL. We're going to learn some SQL commands. And by the end of the series of the video into SQL introduction, you'll be able to use and read SQL. It's pretty much like you can read an SQL command. You will be able to read SQL command like you read English sentence, pretty much, right? So a lot of professions use SQL on an advanced level. While you start as a QA engineer, you're not going to be on that level, right? For example, there are backend engineers or data analysts. They can create a whole set of databases. Within those databases, have multiple tables with different relationship between those tables. For a QA engineer, starting QA engineer, what you really need to do, you should be able to retrieve data from a database, look at the data, and verify that it is correct. For example, there is a price on a web page, right? And the price seems to be a little bit off. So you'll go and check out the database to verify that the price is actually correct. Or maybe some values on the page that are not what you think they should be. So you can go in database and verify, okay, is that section is pulling correct values? Are those values correct? Okay, so something like that. Also, a lot of SQL interview questions for QA engineers, unless it is database testing specific positions. So database testing specific positions might have like an advanced SQL level take-home tasks where you have to create like multiple different SQL requests, structure them, might be a little bit hard. But most of the QA engineer interview questions that include SQL questions are really simple. They will sound something like this. So how do you retrieve all customers that are from United States from customers table? Which department has more than 100 employees? Things like that. So you will be able to type out commands like this and do requests like this after the end of the series of video for SQL introduction. Questions like this are really easy to prepare and answer. So we will be practicing during this video, and I'm gonna use two web pages. So https www.sql-practice.com. That's going to be the first one, and we're going to use www.w3schools.com SQL section. So the links for those web pages will be in the description. You don't have to install anything on your machine. You don't have to install a database. You can just practice online. You can follow along with me, pause the video, type out commands yourself, try to solve the task, or additionally practice more on those pages on your own after introduction. Okay, so how does a database looks like, right? How does it look? So here we have two tables that are coming from a database. We have a customers table and we have an orders table. So here you can see customers table at the top, and at the bottom you can see orders table. This is how it looks like when you retrieve data from the table. In the customers table, you see there are multiple columns, so customer ID, customer name, contact name, address, city, postal code, and so on. So those columns define what sort of data will be stored within them. And then you see records. So each row is a record of some information. So here's customer number 1, all the information about that customer. Here's orders table, order ID 10308, and all information about that order. And you can see there are primary keys. So primary keys are unique identifiers for each record. For example, for customers table, primary key would be customer ID. So each record that is added to the table will have to have a primary key. It can't be null, has to be unique value, because let's say there are twins. They have same name, first name and last name, same address, everything is the same about them. They're twins, they live at the same apartment, right? And both of them are customers. So how can system distinguish one from another one, right? Well, it's done by using this primary key. So for example, if you go and shop in Costco, you have a Costco membership, right? So that Costco membership would be your primary key for your as a Costco customers. So let's say you and your twin, you have different memberships, you have your own cards, you can live at the same address, but the system will know you from your twin, right? So this is what that unique identification is. This is what the primary key is needed for. Another example of a primary key in real life, a value that is unique and belongs just to you. So like your taxpayer's ID number, or if you're from the United States, like your social security number, just unique identification that belongs to you. No one else has it. So this is the role of the primary key, right? To identify a record, to give it like uniqueness. And then there's something called foreign key. And foreign key serves a connection because foreign key references primary key in a different table. So here we have two tables, customers and orders. So let's think in terms of like Costco member and your check. You just went to Costco, you did some shopping, and your check, your receipt has a transaction ID for all the purchases you had, like your transaction ID. That would be your order ID. Your transaction ID is the primary key in the orders table, right? It may have the details on how many things you purchased, how much it costed, who was the cashier or employee who registered you, and it has your Costco membership number. But there's no other information that your Costco membership number. So that Costco membership number can point back to customers table for your Costco ID that will have all the information about you, like your first name, last name, address, how long you've been member for, and so on. So this is how it looks here. So visually, you can see customers has its own primary key, which is customer ID. Orders has its own primary key, which is order ID. But then look, there is a customer ID column that is referencing customer ID column in customers. So you see in orders, there's a customer ID column that is referencing customer ID in customers. So if I'll ask you, if you have access to orders table and to the customers table, if I'll ask you, so who bought order 10355 and order 10383, you can take a look into the foreign key, into the customer ID column. You can see number 4 for the customer. So there are two transactions that customer did. So foreign key doesn't have to have all values to be unique. Like one person can have multiple purchases, right? So primary key has to have unique values. So you can look at customer ID column, find ID 4, and then go back to the customer, find primary key number 4, and find all the information about the customer, right? So foreign key serve to connect tables, and they can reference primary key in another table. Primary key is a required column that will be present, or sometimes set of columns, that will be present in each table, and values within the primary key column all have to be unique for each record because you can't have a record without identifier. They have to be unique. You can't have repetitive identifiers, and they can't be null. So you can't have a record without a primary key, right? Okay, so this is how it looks when the table is returned. Remember, there are primary keys, and there some tables will have foreign keys that allow connecting multiple tables. Now, then there's one more thing that I want you to know that exists in SQL tables, and it's called schema. So schema is a logical container or namespace that holds a collection of database objects such as tables, views, indexes, and stored procedures. You can think of it in terms of database foundation. It's like map of what should go where and how everything is connected. So this is a diagram, an example of a schema we will work in this table today, in this database, in these tables. So here is a schema, a diagram. So we have 1, 2, 3, 4 tables. You can see 4 tables. We can see how they're connected here. Some of the schemas will even have like a little golden key for a primary key column and like a silver key for a foreign key column. So for example, here is a patients column. Within that column, there are here's patients table. Within that table, there are columns: patient ID, which is a primary key for patients; first name of a patient, which is varchar. So that means this column stores text values, and this 30 for the varchar means the text values cannot be longer than 30 characters. So there's column last name with varchar 30 also that stores up to 30 characters. Gender, char, that stores only one character, so male or female. Then birth date column that stores date, data type. City column that stores again varchar 30. Then there's a province ID, and that's a foreign key, and you can see it is connected. So one to one to many connection, so it or many to one. It's connected to province names table where province ID is a primary key. And I will also show you how this looks when we'll be doing like join statements. But essentially, through that province ID, you can go into province names table and get a province name instead of the ID for using the join statement. Then there's allergy columns, height columns, weight columns. You can see there's different data types. So height and weight are in decimals, right? Then other tables that present in this database. So doctors, also doctor ID, that would be a primary key. First name, varchar 30, so stores text values up to 30 characters long. Last name of doctor, again, varchar 30 stores text values up to 30 characters long. Specialty, varchar 25 stores text values up to 25 characters long. Then there is admissions table. You can see it has also patient ID, attending doctor ID, admission date, discharge date, diagnosis. All they have different data types. Each column have different data types. So schema is essentially your foundation for your database. Schema tells how many tables there are, what kind of columns in those tables, what data type was in those columns, how those tables connected, what are the primary keys, what are the foreign keys, and so on. Okay, so let's start practicing with SQL. We will start with some simple commands. So I'm gonna exit this view. So I'll be switching to like a smaller view, slide view like this, and actual window that we will be practicing in. To start practicing, you can go to sql-practice.com. Again, this link is in the description. So you can access it there. Let me zoom this a little bit, maybe. Okay, so let's go and start with simple SQL commands. So one of the first commands that we can try, and you can try in any table, is let's just get everything that we have. So you want to get all columns and all records from patients table here. Here is our database. So let's look at the schema. Here we have patients table, we have doctors table, we have admissions table, we have provinces table, province names table. So we can start by saying select everything from patients. So if I'll do that, if I'll run this command right here, there is a run button. You can see I get back a table. Down here, now there's a response, there's a table. Those capitalized words that are in blue called SQL keywords, and they essentially tell SQL what to do. Here we're asking SQL to start selecting something. Let's grab some data. This asterisk is saying I want all of the columns and data within those columns that exist in the table. So you can see there's column patient ID, first name, last name, gender, birthday, city. So just like in the schema, patient ID, first name, last name, gender, and so on, right? This is patients right here. So asterisk is easy to use because you can get all of the columns and you can know them immediately. You don't know the table, you can get all of the columns, you can see all of them. Now you can get, instead of asterisk, you can get specific columns. You're still going to get all of the records. It's still going to be 4,530 results. So that's the amount of records that's coming back. But let's say I want to have only first name column and last name, right? So you can separate them by comma. Here I selected 2 columns. I'm only getting first name and last name of patients right now. Run it. Here we have first name and last name. Same amount of records returned, just showing 2 columns, right? So let's get back to getting everything. So use an asterisk, run it again. Here we have all the information. Now, from is a pointer, again, another SQL keyword that tells, okay, SQL, you have to do something. So here it's actually pointing to some place. And in our case, we're pointing to patients table. So you can see, you can read this in English, and in English it says, select everything, select all of the columns and data within those columns from patients table. That's how you can read it. That's what this command means. So you can go ahead and type this out and try running it under this link, so sqlpractice.com. You can also try and grab everything from doctors. So let's go and select everything from doctors. And you can see it suggests you, okay, doctors table. Okay, here I selected doctors, run it again. And now you can see it change. So we got doctor ID, doctor first name, last name, and their specialty. You can also see that aside from the keywords that like they're highlighted in blue and they're capitalized, SQL doesn't care for new lines, right? So this is still going to work. And SQL doesn't care for new additional spaces. You have to have initial space. Additional spaces doesn't matter. So I can go back to patients table. It can look like this. I can still run it and it's still going to work. Why is it done? Well, because you can structure your statements that way that it's easier to read. Like I prefer to put new keywords on a new line. So select keyword, my first keyword, so select everything, and then new keyword from, and then patients table. Sometimes you will see a semicolon at the end. So this is just an indicator that it is end of your statement. If you have a semicolon, make sure you have it once at the very end of your command. If you put it somewhere else, like here, and try to run it, it says syntax error. So you're going to break your request. So if you use semicolon, use it once at the very end of your statement. Okay. All right. So we just grabbed everything from patients. Now you can get specific columns, right? As I said. So for example, we can get first name and last name from patients, right? And what do you see here? This table, right? We actually did not change anything. This table that is returned is a result table. That's a temporary table based on your request. Nothing gets changed in the database. You just retrieving information. And doing select everything from patients, you just retrieved all the information that exists in the patient's table. Now, if you want to get like first name, last name from patients, those columns, you can type that out too. So just get first name and last name from the patients. All right, perfect. Let's move to the next one. So retrieving all data is nice, but you also want to start searching for specific data. And you can do it using where keyword. So our statement kind of grows in complexity. The first part stays the same. So we say select everything from patients, right? Run it. We get all of the columns, all of the data. Now we can say where, that's our new keyword that starts the search. Then you need to provide the column name. So for example, gender, and then you need to provide value. So equals and some value that you're searching. So if you're searching for a text value or anything that contains letter, you have to put it in quotes. Double quotes or single quotes, doesn't matter. If you're searching for an integer value, you can put it without quotes, just like that. Now, if you're going to put text value without quotes, so for example, you're searching for all the patients where first name column, right, has name Donald, Donald is a text value. It has an equal, so it looks for an exact match, so it has to be capitalized, starts with a capital D. If you're going to have it without quotes, it's not going to work. It's going to think it's a column. Because it's a text value, you have to put quotes on each side. Run again. Now we have all patients whose first name is Donald. If we were looking for a number value for integer, so we can say patient ID is number 77777, right? Because it's an integer value, column contains integers, you don't have to provide quotes. Okay, so just be aware of that. Looking up text values, make sure you have them encased in quotes. Single quotes or double quotes, doesn't matter. You have to open with the same quote and just close with the same quote, right? Either single or double. So here we have an example where we're selecting, and by the way, you can go into here we have questions, so you can go into questions and you can select different types and questions to solve. So for example, let's go all keywords, difficulty easy, and here's our question. Let's read it. Okay, it has, so show name, you don't have it solved, so you're just gonna see the question itself. So it says show first name and last name and gender of patients whose gender is M. So let's get all of the male patients, right? We can start with requesting everything, so select everything from patients. So let's just select everything first. We did this before. We got the patient's table back. Now we can say, delete the semicolon. We can go to a new line and say where, and then gender, so we're looking into the gender column, equals to male, capital M. Run it, and now we have all of the male patients coming back. Now it says incorrect solution because in the question it asks show first name and last name and gender. So instead of getting all of the columns, we want to get first name column, last name column, and gender column. Run it again, and we got a correct solution. Perfect. Okay. So this is when you need to get some specific value. You know the exact value you want to get. It's going to be an exact match. So you will use equals, right? Now, when you have a missing value is null, you have to search a little bit differently. You have to provide is null instead of equals something. It has to be is null. So some records might have like no first name, no last name, maybe the date of birth wasn't entered. So maybe some information is missing. And you want to find those records that have an information missing. For maybe you need to add this information like allergies, right? Allergies, some of the patients have no allergies to any medicine. You want to find those patients. So in order to do that, you will have to say where. Again, we started our search with the where keyword. Then we need to provide the column that we're searching in. So allergies, that's the column name. And then we have to say is null. So, and run it. And now we have all of the patients that have no any allergies to any medication. If we go into the questions, here is, it's also one of the questions, one of the tasks. So on easy, you have show first name and last name of patient who does not have allergies. So first name, last name, patients, allergies is null. Run it, and here we have a list. Here we have a solution of all the patients with null allergies. If you want to see all information about them, again, you can put asterisk after select instead of column names, run it. And here we are. Okay. Now next slide. So here you can use different operators. Not only equal, you can use larger, larger or equal, smaller, smaller or equal, and even between keyword to find different range of values. So for example here, let's find all the patients whose height, so if we put equal, we can find one parameter. So equals 191, right? Run it, and we have now all patients with height 191. Let's find 250 if there's anyone 250. Okay, no one is 250. Okay, let's find everyone whose height is larger than, let's say, 200. Run it. We got 315 people. Okay, let's do 230. Run it. No one. 220. Okay, couple people. 24. Okay, we got 2 people. So you can see height is larger than 224. So 226, 225. You can say is smaller than 224, and then you'll get everyone else, right? Who is smaller than 224 in height. You can find between. So let's say we want to find people with a specific weight. So we can say select first name and last name columns from patients, and also let's add weight so it's visible. From patients table where weight between 100 and 120. So between those two values, run it, and we got 952 people. So let's say, what is the highest here? Let's do 19. Okay, still a good amount of people. Select all of the columns. Yeah. So the highest is 120. So we got 119. So including 119 and including 120. So 119 and 120. That's all we got here for the weight. So when we have a value that we want to search between, we can use between keyword. Another way to do it is to do with operators. So larger, larger equal, smaller, smaller equal. We can have the same exact request, but just instead of using between, we can use larger or equal to 100 and weight smaller or equal to 120. So let's do, instead of 100, 119. And again, we can just read this as we would read it in pure English. So let's do select everything, select all of the columns from patients table where weight is equal or more than 119 and weight is less or equal to 120. Run it, and here we are. This is our table that's coming back, 120 and 119. All right. The next one, let's do the next one. So sometimes you want to exclude some value. So we're going to use not keyword. And you also want to find multiple values in one column. For that, we're going to use in keyword. So let me show you how it's done. So for example, let's go back and get everything from patients. So select everything from patients as your first step. Now let's exclude everyone who is male. So we can say select everything from patients, and let's say where, then we want to put not, then the name of the column where we're doing search, gender, and then equals to male. So not gender, or gender is not something, right? Run it, and we get back all of the females. Okay? So that's if you want to exclude something from your search. The next keyword is in. Now in, pay attention, instead of equal, we will use in. And then in parentheses, you'll be able to provide multiple values. So let's say we want male and female. and remove not. So in will be used instead of equal because you can't do equal and do a multiple search. It's going to break, right? Equal is expecting only one value here. So we're going to say in, and then you have to put your values in parentheses. Still have to have them in quotes. Still have to have them separated. So let's get all patients that have allergies to, let's do penicillin, for example, and sulfa, right? Run it, and we have penicillin sulfa. So 1,200 patients have allergies to penicillin sulfa. So we provided multiple values here, right? Okay. So the next set of keywords is and or keywords. So first one is and using and keyword, you can provide multiple conditions for your search. For example, here we have select everything from patients where weight is more than 130. Okay, we sorted by weight, so everyone is higher than 130. Then we can add another condition. Let's say and height is higher than what we got here, 213. 213, right? Run it. We got 3 patients back. You will get response back only if all of the conditions are true for a record. So in order for the system to show something back to you, your weight the weight of the person have to be more than 130. The height have to be more than 230. So this and this, so both of the conditions, they have to be true for that record. And there are only 3 records where both of those conditions are true. So patient 2466, weight is 132, so it's higher than 130. Height is 213, is higher than, so have to be more than 213. Height is 224, so it is higher. So only when both of those conditions are met, the value will be returned. So and helps you to narrow down your search, have like multiple criterias for the results to be returned. You can add another and let's say and city have to be, and let's add Waterford, right? Another condition. So when this is true and this is true and this, let's run it. And we got now one record that matches all of those conditions. So by using and keyword, you can narrow down your search, you can specify multiple columns and provide like specific details to get the result back. Okay. There is another keyword though, and it's called or. So you can use or to return any record that is true to either of the filters. So either of the conditions. And let's take a look at this request. So again, select everything from patients where weight is 300 or height is where weight is more than 300 or height is more than 225. Run it, and you see there's only one patient. So weight, is the weight more than 300? No, weight is 121. Height is 226, and the requested height was more than 225, so the height is okay. So it found one criteria in a record that is true, and it returned that record. So for the or record, if either this or this is true in a record, this record will be returned, right? If I will put here and, for and both of the conditions have to be true. So weight have to be more than 300, height have to be more than 225. There will be no such record. There's no such record. If I'll run it now, it will say no rows to display. So essentially, it didn't find anyone that has weight more than 300 and height more than 225. If I will put OR back and run it again, you will see it returns patient 773 because its height is higher than 226. So this was true for that record, and the whole record was returned, even though the weight was false. So true, if one condition is true in OR, it will be returned, right? In the case of AND, everything have to be true for the record to be returned. Okay, let's go to the next one. So here we're gonna practice probably the most useful search that you'll have to remember. It's partial search. So now instead of equal sign, we're gonna use like keyword. So no more equal. So here we said everything from patients, where let's say gender equals to M. The thing is, was equal. Equal is looking for an exact match. If I have, instead of capital M, you see in gender capital M, if I'll have instead of capital M, lower m, and try to find it, it won't find it. Because equal is looking for an exact match, right? Now with like keyword, it's not the case. So instead of equal, we're gonna use like, that's not a keyword. And I can search now and still get value M back, because a like does ignore capitalization, right? Now, another thing with the like keyword, you can use wild characters, so %sign and underscore. So you can use it with where, with like, %sign and underscore for partial search, right? For example, you can use like and underscore wild character to find match with partial value. So here we're going to find, let's find all patients whose last name starts with K. So select everything from patients where last name like K %sign. So K have to be first character, and then here is a %sign, mean anything goes here. Let's run it. I think it doesn't like this quotes. Let's run again. Okay. Yep. So you can see last name, all of the patients is starting with K. K, K, K. We can say we wanted KO. So now it reads like select everything from patients where last name of the patient starts with KO and then anything goes. So because there's like and the %sign, any KO pattern will be matched. So let's run it. Co. Let's say KOW. So at least first 3 letters have to be KOW. Run it. Last name KOW. I think it should find this record. Okay, here we go. Kowalski. And then this %sign means like whatever is there will be included. So all of that part came from the %sign, Alski, right? You can reverse it and say, hey, it can start with anything, but let it end with a special character. So let's find all of the patients whose last name ends with K. Run it, and you see back or bank. Let's say Bach. So let's find all of the patients where last name like Bach, like %sign Bach. So can't start with anything, have to have Bach at the end. Run it, and here we have callback. Now, what if I want just a particular set of things included, right? Somewhere in the middle, not at the end, not at the start. Then you can incorporate values in the %sign from each side. So let's do birth date. So select everything from patients where birth date like %sign 986-10-2 %sign. So can start with anything, can end with anything, but must include 986, 10, and 2. Let's run it, and here we have it. 4 records that include this pattern. So any pattern, if you want to match any pattern, like if you want to match a pattern that you provide, encase it in the %sign. You can also find like separate words and spaces. So what if I want last name that has 2 words in it? So where last name like %sign space %sign. This can be a whole word. This can be a whole word, and there have to be a space in between. Run it. Okay, so there are no double last names. What if it has a dash in between? Okay, here is a dash. All of last names with a dash. All right, so we know how to find records that start with a specific character, end with a specific character. We can find characters with a specific pattern. So let me just copy this. By the way, 2 dashes over here, this is a comment, right? SQL ignores comments. You can say this is bananas. SQL gonna ignore it. So developers leave comments in their code so they can know what the code does. They can come back to it, read it, and understand what they were writing. So the comment is going to be ignored by SQL. This is for us. But we look in any last name of a patient that has RL anywhere in the name. So %sign, RL, %sign. Run it. Go to the last name Arley, Pearl. So Arl, Arl. All of them have it, right? And then with the underscore, if you play like Wheel of Fortune or saw it on TV, right? It's just one character that is missed. You can have multiple underscores. So let's say something like this. Select everything from patients where first name like G_A. So first name have to start with G. Second character can be anything. Third character have to be Y. So if I'll do a search, I have all the first names where the first name is Guy. So this one character, one underscore, was filled. I can have underscore Y. Now I have Amy, K, so 2 first characters can be anything. The last one have to be Y. I can have just 2 underscores, so any first name with 2 characters will show up because it has 2 underscores. If I have 1, well, no rows found, so there's no match. Okay. All right. And you can also combine them. So here's an example where we're searching by city. So select everything from patients where city like R_D, %sign, R_D space %sign. Run it. So it means that city have to have 2 words. First word have to start with R. Here's R. Second character can be anything. So here's E. Third one have to be D. Here it is. Then have to be space. There is a space here. And then anything else after that. Any other thing. And we have Red Deer and Red River. So a bunch of cities, bunch of patients from Red Deer and Red River. So it can be river here, deer, or anything else that it is in the table. All right, perfect. Now we can also order by specific order in ascending or descending order. So here is one example where we can select all the patients or select all of the columns from the patient's table, and then we can order by height in descending order. Let's run it. Now we have the patients from the highest to lowest, from 226, 225, 224, and down to the smallest height. So we can order by descending order, or we can order by ascending order. Ascending order. So that will be ascending. Why is it not working? Ascending, run it. Okay, here we go. So by ascending order, select everything from patients ordered by height in ascending order. So from the lowest to the highest. 25, 26, 27, and so on. See, it goes from the lowest to the highest now. So you can order by specific column in ascending or descending order. All right, perfect. Now, this one we will practice in another table in W3 Schools SQL insert. You can have this link in. You can find this link in the description. But we can insert information into a table. So let's go here into this W3 School insert to. You can see here there's also a bunch of keywords, and all of them have description, introduction. So if you want to spend some time, additional time reading about different keywords and practicing them, you can do that here. So let's go and click on try it yourself. All right. Gets us to this SQL statement. So I'm actually going to go probably to the shippers. So shippers has only 3 columns and 3 records. It's kind of easy to see the impact. All right, so we're in this console, same console as here. You know, this console talks to the database behind the scenes. Right now, we just selected everything from the shippers table. We can add, insert info. So for example, we can insert info without an ID, right? There's always have to be an ID. And ID is a primary key. If you don't provide it, it will be auto-populated and it will be just incrementing. So from 3, we're going to go to 4. In order to insert value into a table, you have to type insert into name of the table. So shippers, that's the name of the table right here. Then you have to provide column name and corresponding value. So shipper's name will be Alex USA Days, and then column name phone, and the phone number going to be 888-555-9831. So in the first line, we here provide insert into shippers and the columns, and then we say values, and we provide values, and the values will be corresponding in order with the columns that you have. If I run it, it did not recognize this comma. Okay, updated the comma. Run it again. Changes have been made. Row affected 1. Okay, let's get shippers one more time. Now I see that new shipper was added. Alex USA Days was added into the shippers table, right? Now we didn't provide shipper's ID, but because it's a primary key, it was automatically generated. I do not recommend it, but if it is absolutely necessary needed for your testing, you can even insert with an ID provided. So you can say insert, so insert into shippers. Now you can say shipper ID and then the provide ID that you want to insert. So same thing, insert into shippers. So that's the keyword. That's the name of the table. Shipper ID is the first column. Shipper name is the second column. And then this is the third column, phone, right? Let's insert this. 10, Alex USA Days, and the number. Again, I have to update this quote. Okay. Open shipper. So now we have record number 10 added. One more record was added. Was the primary key that we provided in the request. Okay, perfect. Well, sometimes maybe we don't want to provide any values, just one column, one value, and you can do that. For example, you add in something for testing, how the data gonna come back, where there are null values, maybe on the front end from the back end, right? So you can say insert into shippers, and I'm gonna just insert the shipper name. This is crazy, and nothing else, and run it. Go to the shippers. You can see, yeah, the primary key started incrementing from the last value, so from 10, from the value that we manually provided, it was added 11. Here's our this is crazy value that we added, and then there's null for the phone. So no phone was provided, nothing was populated here. Okay. All right. And then there's update. So you can actually update specific records. So let's say also you can do it for testing, for SQL testing at your work. You need to update some test values to be whatever. So for that, you have to go with update command, and you can issue update as your first keyword. Then you have to provide name of the table, so shippers. Then you want to say set a column, set shipper name column, and then value, what are you updating it to? So we're gonna update something in the shipper name to we updated this. So some of the shipper's name will be updated to the we updated this text. Where, now here's your condition, where shipper ID is equal to 10. Where is our shipper ID? Here. So shipper ID 10, this shipper name will be updated to we updated this. Let's run it, get the shippers, and look at this. Shipper ID 10, shipper name, we updated this, and a phone number. Okay? All right, so now we get we get to the most hard part, joining multiple tables together. Now, we talked about primary key and a foreign key at the very beginning of SQL introduction. So let's practice join, how we can do this, right? So in order to get join request, you need to add another table into request using join keyword, and then specify primary and foreign key connection. All right, so for this, I'm going to go back to the Learn SQL here. And this is the statement. Seems a little bit crazy first. Let me comment it out and kind of dissect it. What are we doing here? So I'm going to just put comments. So this will be for reference for now. So very first thing, let's do this. We're going to select everything from patients. Let's run it. We did this before. Here's all the patient's data. Perfect. Now, I want to have some other values showing. I want to show the province the patient is from, but not with ID, but actually a whole name. And we're here in the schema. We can see there is patients. We're in patients right now. And it's connected. The province ID is connected with the province ID in province names. So as I said here in the slides, first we need to join table, and then we need to provide connection. So if I'm joining patients with province names, I need to do that. I need to say join province names, right? Province names. Okay, I can run this, but that's going to be a mess. So this is not it, right? Yeah, I think it even hanged. Yep. It actually hanged. So because when you join it without providing any details, it's gonna create like, okay, what is going on? It's gonna create a record for each table, for each column with another column. So that is not gonna look pretty, right? And when you have like multiple records, it's definitely can break your response. So let's do select everything from patients again. So we just requesting everything from patients, run it, here we are. Now we're joining, join province, province name, names table, right? Now we need to provide how they're connected. In order to do that, we start with on keyword, and then we need to provide table name column equals to other table name column. So if we look at the schema visually, we need to say, okay, we just joined in province names, but we need to say patients dot province ID is actually equal to province names dot province ID. So we need to specify this relationship. So let's go and do that. So we type just the name of the table. So let's do patients dot province ID is actually equal to provinces names dot province ID. Okay, so we specified this connection now. We can run it, but because we have asterisk, it means it selects everything. All of the columns from one table and all of the columns from the other table. We don't really need this much information, right? So I only want to know first name and last name. And how I want to make sure it's coming from the right table, I can specify table name before the column name. So patients dot first name, patients dot last name. If I run it, now I have first name and last name. So those two columns are coming from patients, but I also join provinces names, and I can say provinces names dot province name column. So this column, province name, will come from province's name table. Run it, and here's province name. We can also have patients, and let's add province name, province ID. So you can visually see the ID. So Ontario and so on. So now we join two tables together and got columns from different tables. One thing though, you can see how you start typing out table name and then column name. It can get a little bit long. So first time when you pull a table in, you can have an alias. You can say as to make sure it is an alias. Give it alias. Let's give alias to the patients. Give it P, and then let's give alias to province names column, province names table as PN. Now everywhere else you use the name of the table, you can substitute it with an alias. So everywhere else you can use, for patients you can use P, not where you pull it, just everywhere else. And then for province names, you can use PN. So the alias that we give here. Now it makes your statement a lot shorter. So delete this comment, so run it, and here we are. So we're selecting from patients table column first name. Here we're selecting from patient table column last name. Here we're selecting from province names column province name. Here they are, they're all showing. Now here we're saying from patients as P, so patients table is pulled in and alias P is given. Join province names, so province names is pulled in and then alias PN is given. And then on, we're providing this referential integrity. We're telling how those two tables are referenced, how they're connected. So patient's province ID values column is actually equal to province names, province ID. All right, we can put a semicolon at the end. Here's end of our statement. We did our join. And that's it. We're done. So how QA engineer, what kind of testing QA can do on database? You can ask, right? Okay, what do I do with all this information? Well, when you work with database, you can verify database design and schema in documents versus actual return values. So you can take a look at documentation of whatever for the test scenarios, right? For the business case, you can go to schema and say, okay, so patients have to have patient ID as a primary key, province ID as a foreign key, and province ID have to be char 2 and maybe it's char 3. You can verify all of this, like you can verify the schema itself. If is this schema correct from what is actually existing in the database? You can verify columns and data types and what are primary key and foreign key. So you can verify all this within database, right? In documentation versus actual implementation. You can verify tables, data type in the columns, rules set in columns. You can verify if the data coming back is correct, right? There are no typos. Unique values are unique. Null values are there if they're expected or not expected. You can verify how invalid data is handled. So there's a bunch of things that you can do with SQL. Now, at the very end, I'm going to give you a very good life hack. If you have a specific like task on SQL, maybe it's in the form of a test case, how can you actually use ChatGPT to help with your SQL needs? So let's go ahead and grab a question. So I'm going to hit fuel questions in sqlpractice.com. Let's say here is here's a task. Show first name, last name, and the full province names. Okay, we have this completed. Show first name and last name contained into one column to show their full name. All right, let's grab this request. Let's go to ChatGPT and let's ask it. We can specify, that it is SQL, but it knows, right? It already knew. So we can grab the response from ChatGPT, go back here, issue it, let's run it, and here we have it. So what ChatGPT did, it grabbed your question, analyzed it, understood it was SQL, generated a response, and you just grab the response, put in console and says select, and then concatenate first name and last name columns with a space in between, and show it as, the alias as a full name, right here, full name, from patient's table, and it returned, instead of last name and first name, 2 columns, it concatenated them and returned them here. So ChatGPT is pretty good tool in terms of helping out you with building SQL queries, solving like SQL tasks, building SQL test cases. So yeah, make sure you use it. Okay, so that's it. One small announcement, I updated my Patreon page. I'm gonna also provide it in the description, updated tiers. So you will see, okay, here we go, tiers. So you will see multiple tiers. Now I got 4. So quality cadets, just for the support. There's like early access, behind the scenes constants, when there are polls exclusive within Power. There is assurance gurus for 5. So this will have live Q&As when I have those, and work in progress updates. So if you want access to the slides, that's going to be with this subscription in Patreon. So link in the description. There's also $10 a month and credits QA. So I will include whoever subs for this. I will include your names in post credits for the video as a thank you note after each video. As long as you stay here, I'll add your name at the end of the video. And then at $25 is quality assurance one-on-one, so we can have like a 30 minutes call, talk about QA career, go over interview questions, talk quality assurance. So a call once a month, but you have to be sub for a month. All of those higher tiers subs include all the previous benefits. So yeah, link to this also in the description. That's it. Hopefully that wasn't too much. Thanks for watching. This was Alex USA Days, and bye bye.